So let's now derive the derivatives of tangent of x and also cotangent of x. And as I mentioned in the previous video, when I find the derivative of tangent of x, rather than trying to use the limit definition, let's just find the derivative of what tangent of x is equal to, which is sine of x over the cosine of x. This is the quotient of two functions, so I can use the quotient rule to find this. This equals, if I just kind of remember that mnemonic I taught you for quotient rule, low times, so cosine of x, d high, so the derivative of sine of x, minus high sine of x, d low, so that's going to be the derivative of cosine of x, all over low squared. And so remember, whenever we square a trig function, that's kind of to remind you of some of the notation of that. The cosine of x, all of that quantity squared, we write as cosine squared of x. And this removes a little bit of ambiguity that might occur if I just wrote the cosine of x squared. You wouldn't know if it was the cosine of x, quantity squared, which is what we want to imply, or if it was the cosine of x squared. And so that's how we write the cosine of x quantity squared, is we'll write the exponent in between the cosine abbreviation and the argument. So that's the denominator squared for this particular application of the quotient rule. So now let's take the derivatives here. We know the derivative of sine of x is cosine of x. So I end up with, in the numerator, cosine of x times the cosine of x minus sine of x, and the derivative of cosine of x is negative sine of x. And this is all over cosine squared of x. So if I look at what this numerator comes out to, cosine of x times cosine of x is cosine squared of x. The negative times negative becomes positive, and then sine times sine is sine squared of x, all over cosine squared of x. And if you look at this numerator now, that's cosine squared plus sine squared. We can use the Pythagorean identity and say that's equal to 1 over the cosine squared of x. And so you might think we're done. Remember, 1 over cosine is secant, and so kind of the universally accepted derivative for tangent. The derivative of tangent of x is, we rewrite this, rather than saying 1 over cosine squared, we say that that is secant squared of x. And so there's the derivative of tangent. The derivative of cotangent is going to look pretty similar. So I'll take the derivative of cotangent of x, which you'll recall is the reciprocal of tangent. So it's the derivative of the cosine. Let's put our derivative notation there. The derivative of cosine of x over the sine of x. So I'm going to take the derivative of cosine over sine using the quotient rule, very similar to what I did over here with tangent. Well, this equals, using my quotient rule, sine of x times the derivative of cosine of x minus this cosine of x times the derivative of sine of x, and this is all over the denominator squared, which is going to be sine squared of x. Now then, let's take these derivatives here in the numerator. So I get sine of x times the derivative of cosine, which is going to be negative sine of x, minus the cosine of x, times the derivative of sine of x, which is cosine of x, and that is all over sine squared of x. Now then, if I take a look at the numerator here, this is going to be negative sine squared of x, and this is going to be negative cosine squared of x. So in order to get it to match that identity, I'm going to go ahead and factor out the negatives and say that that is equal to negative sine squared of x plus cosine squared of x all over the sine squared of x. In this grouping, I now have what I can replace with 1 using the Pythagorean identity, and this is negative 1 over sine squared of x. And just like over here, how we wrote 1 over cosine squared, we're going to write the negative 1 over sine squared and say that the derivative of the cotangent of x is equal to negative cosecant squared of x. And so there's the derivative of tangent for you, and there's the derivative of cotangent. And if you haven't started yet, it's probably a good time to go back and look at a lot of the derivative rules we learned in Unit 2 and start making either some flashcards or however it is that you remember things, because just like how the derivative of sine is cosine and the derivative of cosine is negative sine, these are also going to be derivatives that you need to know, as well as in the next video when we find the derivatives of secant and cosecant.